Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Encore. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but first, I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you would like to rewatch or share, the on-demand recording will be made available shortly after we conclude our webinar today. If you have any questions, we want you to send those into the Q&A tab on the right side of the screen. And that's also where you'll find our chat tab. This is where we want you to just talk with your other audience members or let us know from where you're tuning in. We do have 3 polls close to the beginning of our webinar today, so we want your participation there. And we also have a resource available for download in the Handouts tab, so you can download that at your own convenience. Finally, of course, at the end of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is container security best practices for 0 days. And I am joined today by Hayden Smith, Technical Director of Solutions Engineering at Encore. Hayden, thank you so much for being here with me today. I'm going to give the floor over to you.
Thank you, Cody. Yeah, thanks for having us. I think today we'll just kind of walk through. Let me go ahead and start bringing up the presentation here. Let's see. Boom. Okay, so Cody already went over some housekeeping items. So, just a quick reminder here. About Encore. Encore is a software supply chain security tool that exists to provide a frictionless developer experience that enhances security at every stage of the SDLC. So moving forward, just the agenda today, as Cody mentioned, today's topic is container security best practices with a focus on 0 days. So everything from identification to triage and how certain aspects of Encore can help, your organization along the way in that process. So we're going to provide an overview of the impact of 0 days on software supply chains. So we're going to first look at, what the software supply chain looks like, and then marry it up with the security problem that is 0 days and 0 day proliferation in the software supply chain, and how you can, help identify that and mitigate that with Encore. We're going to talk about best practices for building images securely. So some quick do's and some quick don'ts, just low-hanging fruit that any organization can adopt to get going quickly with container security and start moving in the right direction. We're going to talk about creating policies. So policies centered around security and compliance that help gate, what is allowed to, promote in your software, what software is allowed to deploy and run eventually in that runtime environment, and then generating and using SBOMs. So, SBOM is a fairly new term for a lot of development teams. It stands for software bill of materials. So a complete inventory of all the packages and files and software being used by your development teams as they go and build software. We're going to talk about how you generate those and the importance of using them and how they factor into this 0 day response and how they factor into supply chains. And then we'll talk about continuous scanning and monitoring across the SDLC, which is what we'll close out with. And then before we get going, we'll first do some quick polling questions. So Cody, I don't know if you want to run those real quick.
So I've gone ahead and launched our first poll, and so I'll read that out loud. Our first poll reads, what is the adoption of containers in your organization? And this one is, I believe, just select one. So A, none. B, just getting started with containers. C, some adoption of containers. D, significant adoption of containers. Or E, mostly all or all applications are using containers. I'll go ahead and put these results on the screen as they come in. So Hayden, you should be able to see those numbers on the screen. Perfect.
Oh yeah, it's a live. I like it. It's live, so it's Let's see, some adoption of containers. That's a pretty normal mix, what I see like out in the field. We have some people ringing in with none. About 25% saying they have significant adoption. Um, let's see, just getting started with containers, first few applications. Yeah, this is actually a very typical split from kind of what I see in my day-to-day activity talking with customers and organizations. And for the just getting started with containers, I'm happy you're here because this is an excellent first place to start, before you even go into this kind of new adventure with containers and packaging your applications that way.
Well, it looks like our responses have begun to slow. So we've got a nice little bell curve in this poll question.
Yes.
All right, and you want to go ahead and discuss the second poll?
Yeah. So I'm not seeing the second question, but
Yes.
Here we go.
So, what is the overall level of impact of Log4j on your organization? We have A, significant impact, B, moderate impact, C, minor impact, D, no impact, or E, you just don't know or you're not sure.
This will be interesting. I saw a lot of organizations where it's like you either are impacted or you're not. It's moderate impact, minor impact. I'll give it a couple seconds to kind of even out. Mm-hmm. Yeah, what's interesting is that it's just the small percentage that says there was absolutely no impact. Awesome. Yeah, I think what's interesting here is like the minor to moderate and like what bridges and justifies that definition, right? Of like, hey, this, adversely impacted my organization. And with the significant impact, that's a pretty, large percentage. If, a fifth is saying that they were significantly impacted. So that's good. We'll talk a lot about Log4j today and focus on that as, a problem / case study.
All right, and we ready for poll number 3?
Yes, absolutely.
All right, so what challenges did your organization have around Log4j? So, A, production applications and systems were exploited. B, we had to block or limit access to some production applications. C, it was difficult or time consuming to identify all of the software that has Log4j. D, it was difficult to remediate Log4j. Or E, we are still remediating Log4j.
Awesome. What's not awesome is the production application systems were exploited. But I hope that didn't last for very long and they were able to identify and triage that pretty quick. Yeah, a lot of people after that Log4j, disclosure fell into those kind of middle two categories where they didn't know where to start in terms of identifying the impacted software assets. So identifying, applications that were relying on the Log4j package. And then a lot of groups that, did fall into that group also kind of fell into that purple red group where they had to block a lot of their production applications because they were, reliant on that package, and it took time to upgrade. And then, we'll talk a little bit about it, but it wasn't just, one patch, right? They had like 3 separate patches that came out because each patch had their own kind of vulnerability. So that's one of the problems when we're talking about 0 days, but we can help walk through that in a little bit more detail later in the webinar. Fantastic. Okay, so we went through those questions. I now have like a really good understanding of where the audience sits in terms of container adoption, Log4j response, and how impacted organizations and teams were from that. So let's dive in. That poll you just took, we gave a very similar poll to industry. This is the ANCOR 2022 Software Supply Chain Security Report. What's interesting here, just looking at all the different colors on this color wheel, the small percentage, right, that's saying they were just not impacted by a software supply chain attack in the last 12 months. There's been multiple, right? So it doesn't have to be like the big one. It doesn't have to be SolarWinds, right? It can be something smaller. So it could be something like you were developing software and there was a typo squatting package that you accidentally pulled in, or one of your teammates pulled in, and something like that. So it could fall into those minor or moderate impact ranges, or like a significant impact where you're talking about maybe there was a breach because of it in your organization, or an application was taken offline or something like that. But it's a serious problem, and it's a problem that's not going away anytime soon. And then when you talk about, another thing we asked about in that survey, which again, everyone answered here, which is the impact of Log4j and the before versus after Log4j impact that we had, right? So you can see the results there. And what's important here is 13% more organizations reported moderate to significant impact from a software supply chain attack after the Log4j 0-day vulnerability. And I think the reason that is due to the fact that it was a 0-day, right? But software supply chains were like really relying on that, and teams were relying on that package and bringing that package in because it was so widely used. And I think CISA actually said this was one of the widest used packages in the world in terms of software development. So seeing how many more organizations were actually impacted by that compared to just SolarWinds, which was more like vendor specific, was significant. We're going to talk about how 0 days infiltrate the software supply chain, right? So what you have here is really a oversimplification of the software supply chain itself. So when you're building software, you have your organization right there in the middle, and you're doing your little software development. I think that's like a little coffee emblem or something in the upper right-hand corner, which is definitely needed. And when we're talking about these kinds of topics, so you're pulling in software, right? And you're pulling it in from different suppliers, and those suppliers may be building, they may have a different definition of, software security in their organization, or a different standard of what packages they can use, which ones they can't, which licenses they can use, which ones they can't. And they pull from other suppliers, and those suppliers may also have a different standard or definition on what packages they can use, right? So you have this really complex problem, and then when you start developing software, you're ultimately relying on the software security standard from a upstream project that you're pulling in maybe 2 degrees of separation away, and then you're developing your software in-house, and that gets shipped, right? So you're packaging stuff up from maybe, again, that 2 or 3 or 4 degrees of separation of upstream software packaging away, including it in your project within your organization, and shipping it to either a commercial customer, a government customer, or maybe it's just an application that you source for internal operations, right? And that log, and in that case, when you see these red little emblems, right, you can see if there was a breach, or a vulnerability in that far left column where you see supplier on the bottom and you see that little red emblem, and then it proliferates even further, right? That can be a problem, and it can track or trickle down all the way to consumers. 0-day challenges. So now we're going to talk about, we covered like the software supply chain, kind of how that works at a very simplistic, high level view. But we'll talk about 0-day challenges now. So we'll use Log4j in this example. And then, in that middle part of the screen, you see code repos, build scripts, container registries, Kubernetes clusters. This is just to represent like the cloud native aspect where we see a lot of customers deploying and running applications today. So two big questions, right? With Log4j and any 0-day, you can swap out Log4j and place anything else in there. Where is Log4j, or where is 0-day XYZ? And which applications are vulnerable? So these are the two main questions that you ask whenever you're walking into that 0-day response. Is identification. So identification of impacted assets, and then immediately streamlining that identification output as an input into triage, right? So, how do we go in and start remediating some of these impacted software assets? Some things to think about in the bottom. So time consuming, manual process to scan for the 0-day, right? So if you just have a one-off scan, or maybe just scanning against like a local repo and all your developers are doing it, that's great, but there's no way to really centralize and aggregate that data to go through that, right? So if you're just focusing on code repos, and your developers are really, scanning away and just doing independent checks, it's hard to kind of verify that and validate that it doesn't exist or proliferate anywhere else into the environment. Many scanners fail to identify components, creating risk. That's another important aspect. A 0-day can recur if build scripts and dependencies are not updated. So when we were talking about this cloud native environment, right, if you have either a code repo or a build script that locks on to, say, the Log4j package, it may not matter if your developers are scanning constantly for Log4j. If that build script is never updating, like, sourcing that package to include during build. So if it's locked, if there's like a package lock on Log4j or something, and it continuously pulls in Log4j, if you never update that, what's going to happen is you're going to build something in your code repo. Something's going to bring in Log4j during a build script in your kind of CI step, and then eventually that will move to your registries and Kubernetes clusters, and that's hard, to gain insight there if you don't have a tool or capability to really triage or identify, okay, where does this 0-day proliferate, right? Where is Log4j? Going back to that, right? Where is it at any one of these phases? So that's another really big problem. And then another big thing is, like I was saying, if you're, using resources to respond, so actual human resources, and having the team to go, okay, we need to go find out where this 0-day is and which applications are vulnerable and which code needs to be updated. Development's slow, so you can't really move forward when that's happening. And that was certainly something we saw working with a lot of organizations over the course of Christmas, responding to Log4j. Current challenges with scanners. So most scanners focus only on one stage of the process. So they're not really going back to the first problem. Where is it? I mean, like a lot of security problems really originate with like the 5 W's you learn, like the who, what, when, where, why. But it's pretty simple in that regard. So like, where is it? Why is it running, right? What's in there? So where is it running? So people like to focus on like either source, so like scanning source code, building, so like focusing on building and staging, so like focusing on like scanning during CI, or like somewhere in runtime, right, where it's like, okay, how do I fix this impacted asset, and how do I trace it back to where this asset came from? That can be pretty difficult if you have a running container, in Kubernetes, running as a pod, and providing that traceability back to the impacted source code repo, right? So you have that blind spot, and with that blind spot in place, you can't really see. You don't have that traceability to say, yes, so this container belongs to this dev team, and I can go in and provide them feedback. Okay, you need to go remediate this impacted asset because it's impacted by a 0-day. 0-day vulnerabilities can recur. So we talked about this on the previous slide a little bit, but if you're not updating dependencies in your source code, like in your source repo, you could continuously pull that impacted asset in. So updating or upgrading to certain versions and making sure your tool is able to do that is super important during build, right? So like I said, if you have a lock on a certain package that's impacted by a 0-day and you continuously allow that to be built, dev teams really don't stop unless like there's interaction from like a security org that says like, hey, we're full stop on building because we have to go through and redo the pipeline so that you guys aren't continuously pulling log4j. Sparingly do I see that used. I actually see, developers just continue like, normal day in the life, make my coffee, log back in to start, my Tuesday, and I'm going to continue building my software project that I was working on, yesterday, and continue to source the same stuff because, maybe I'm not aware. And then as you move into deployment and runtime, if you don't have something in there like a policy or something to detect, what's going on there, you're going to continue to allow that proliferation. And then also like the jar, this is the problem with log4j, is that sometimes you may not see it because certain scanners may not go deep enough. So just the way with how that works, right? You may have a jar within a jar, which, commonly was the case with log4j. So you may have too many false positives. So what happens with a lot of false positives is they just eat up response time. So if they're, populating too many false positives in my security tool, I don't know where to focus my priorities, right? I don't know, what to focus on. So it's really important to tailor those out and to have, scanning capability that can enhance that feature as you move through that 0-day kind of response lifecycle. Okay, so now we're going to talk about image best practices. So kind of starting from the top, what should you be looking for when you're building software securely? When you're starting to adopt containers at scale, what should you be focusing on when it comes to how to build a secure image? So one thing that you can focus on is using multi-stage builds. So images are based on layers, so you don't want to make a super beefy image. By beefy, I mean something that is just a huge image. It's a composition of multiple layers and brings in unnecessary packages that maybe you don't need. So you don't want to stash packages that you aren't going to make use of, right? You can actually do away with them. And only provide this, the packages and that are in licenses and files and everything that a container needs to run. So really slimming those down, which is how you get the term slim or minimal. You'll see those with a lot of open source projects. So that's like that fourth bullet there, right? If you're pulling like Alpine or Debian or Ubuntu, a lot of them have like a slim or minimal image that says, this is a very slim and minimal image, right? It only has the necessary packages that is needed for this to run. And then the third bullet I'd like to focus on a little bit, which is avoid hard coding private and sensitive information. So you do not want to put anything like, keys, leave those in there, which does happen occasionally. And I've seen it happen too. So definitely avoid doing that. You don't want to leave like AWS private keys, any kind of, personal access tokens or anything like that. Sometimes that can happen if you're just getting too carried away with Control-C and Control-V and just copy and pasting, and stuff gets left behind that developers miss. And then the last bit, I think everyone knows this as they go into containers, which is don't use the latest tag. Be specific about versions, because versions help tell you what fixes are available, what fixes have been made, right? So with any version of anything, they're trying to upgrade and make it better for the end user, right? So the latest tag, you don't really know what's in there or what you're getting. So this next one talks about building a walled garden of content. So don't use externally hosted content. So this, when you're pulling from external hosts, a lot of times people can push like fake packages in there. So if I was, pulling OpenSSL or something like that, someone could drop an extra L in there and then you'd pull that in, or something like that can exist with Python packages. That happens quite a bit. So you could see, developers or nefarious actors that go in there, push an impacted package into, upstream hosted repo, and then it gets pulled down and sourced by development teams. So that can be a headache. So that helps avoid dependency squatting. Vet OSS content. So really, if you're sourcing OSS content, perform vulnerability scans on that. So if you're pulling, other images, there are certain tags of images that you're pulling off Docker Hub or any public place. It's important to scan that for vulnerability scans, scan it for malware, scan it for secrets, right? Like you want to make sure those developers, going back to the software supply chain, right? You want to make sure you're vetting and validating the security of what you're pulling in to provide to your organization and development team. Removing unnecessary, image content, that's another thing. So if there's certain OS system issues that exist, certain packages that need to be fixed, really focusing in on that and focusing in on what is the priority of your developers, what they can fix from a security and compliance perspective, is really, really critical to making the developer experience as frictionless as possible and, allowing them to do their job. All right. I'm going to pause for a water break real quick. And now we'll talk about policy. So if we take, software supply chain, 0 day, everything like that, and we married those two together, now we're going to talk about, and we talked about creating containers in a secure manner. We could talk about policy best practices. So using policy or repeatable rule sets that can gate and control which software, is allowed to promote through your pipelines, which software is allowed to be built, and using policy as well to detect stuff in runtime. So providing, coverage at every aspect of the SDLC, not just one, right? So we're trying to avoid those blind spots that we saw on previous slides. So we want to provide that holistic coverage by using policy. So when we look at some policy best practices, we want to use a layered approach, right? So there's a good example on the right. So you can have team-specific policies. So, my team uses this version of Python for development. You can have language-specific policies, right? So layer on top of that, you can have approved versions of Python, approved versions that your team may use. And then you can have on top of that, just common best practice stuff. So I like to tell, teams that I work with and organizations, these are information security best practice type stuff, right? So things like don't leave the user as root, leave the user as, what that application needs to run. Don't have passwords and secrets left in your images, right? That can be seen, used for an attack later down the line. So it's important to layer those up so that way you have, additional coverage. One thing to keep in mind is that not all applications are built the same. So, application team A may have, different requirements, different security requirements than application team B. So having the ability to map policies specific to each team is certainly critical. And again, that kind of factors into providing that frictionless experience, because if you're monitoring, or let's say you allow a certain CVE or a certain security or compliance, issue, you've accepted the risk for one application. You don't want that to be allowed for every single application. You may want the ability to do that for certain things, but for things like which CVEs are allowed for this application, you want to be able to have that granularity and focus on that, right? So you want to be able to get super granular and tailor that in to your policy enforcement. Different teams want to be notified, right, about different things. I kind of already talked about this, but if you have a certain policy that's alerting for a certain CVE that may be critical to one team, it may not be critical to the others. So tailoring your notifications and hooking them into the policy enforcement rules, so that way if you have policy enforcement being hooked in against your source code repo or being hooked in against CI or even runtime, right? Whenever one of those gets a positive hit, you're able to kick off that notification workflow in an automated way. Again, tailoring down or tuning down the amount of human interaction necessary and tuning up, your tool to handle that for you. And then I think the last bullet, I already talked about embedding it into kind of every step of the SDLC, rather than leaving like a final certification step that can be handled like by a human, that can be handled by, the tool itself. So let's see, kind of already talked about this, but we're focusing on leveraging automation. Let us do the work for you, right? We can't allow developers to get back to their jobs of making good software and pushing it out to customers and creating new features to enhance the user experience if they're constantly hung up or blocked by security, if they're constantly blocked by a policy. So we have to create policy-based reporting and alerts to automate those notifications, so that way they can get them as quickly as possible, and those notifications have valuable information in there, right? So in this case, in the screenshot to the right, we see a piece of software that's impacted by this log4j vulnerability. And then on the right, you'll actually see two things. So you'll see a fix available, and this is like in the third column from the right, you'll see a fix available. Okay, there's a fix available for this image. Yeah, I might make the fix. You know what I mean? And then you go, okay, this was not inherited from the base image. So in that initial from line that you have in a Docker image, you could say, Anchor is able to tell you this was not coming from upstream, right? You, the developer, are bringing in this log4j package. Therefore, it is your responsibility to fix this. Got it. Okay, so it's not inherited from base. There is a fix available for a critical CVE. Yeah, got it. Now I could go back and upgrade this package and remediate the CVE and continue with my day, right? That's, a few hours work or a day's work, right? You want to be able to customize policies to create that stop signal. So that workflow I just talked about, you could go into Anchor and say, okay, I want to, create a policy that says if it's not inherited from the base, if there is a fix available and it's a critical CVE, then we're going to stop it, right? Or you could be, more strict, and you could say anything that's greater than or equal to a medium CVE, we're stopping outright. So it's really up to you, but the important thing is having a tool that can be tailored to your organization and to different teams and different applications used by those different teams within your organization. And then the third bullet is use out-of-the-box policies to block critical vulnerabilities. So by default, like Anchor, all of our policies will do that for you. So you just get to plug and play for the most part. Okay, so we talked about containers, secure practices for those. We talked about 0 days. We talked about software supply chain. We talked about a lot of blind spots that exist within those. And now we're going to talk about SBOM best practices. So SBOMs are really a critical part of the solution, to solving the software supply chain madness that we just saw, on previous slides. Okay, so why SBOMs are imperative. So here you see on the right-hand side, just to give you, a rundown of what you're seeing right there, that's a screenshot from our SBOM tab within Anchor, where it took either a source code repo or it took a, image, and it went ahead and built an SBOM against that. So it's looking at all the different OS related packages, and then beyond the OS, looking at all the language specific packages. So looking at, things like npm packages, Ruby gems, Python, certain jars you may bring in. So it's looking at all of those, and then giving you, the rich context of, where was the origin of that package? What was the license attached to that package? How big was that package? Again, like the who, what, when, where, why stuff. So going back to this, so if you're focusing on building SBOMs just in source code and just in runtime, that won't be sufficient, right? So I may have source code in my GitHub repo and I'm scanning it, and I may have, 10 CVEs. After I go and build an image, that Docker file may call and bring in, external packages in itself because I need them. I need them for that application to run. So I may go in and build from that source code repo and bring in more packages that could, enhance, that vulnerability posture or that security posture for that repo. So not only will the SBOM change, but now that I have a new SBOM, if I run it and do a vulnerability scan against that during, say, CI, it will look totally different than what you had in source code. And same with runtime. So, SBOM we like to say SBOM is a bridge that shows how the container evolves in the pipeline. So kind of in that workflow, and I think we'll cover this in a later slide in a better diagram. We'll focus on, okay, how does that container evolve from, when I start building it in my repo to during CI, do I call in or do I call out and bring in any external packages, and how that changes my SBOM? And then how does my SBOM change once it hits that Kubernetes cluster? So say I do build out, all my policies. I'm using Anchor policies out of the box. They're doing the job. I'm passing my scans. And then they move into runtime. So they start, living and breathing in your Kubernetes cluster, and then, that SBOM could change there. So having, a tool like Anchor provides Kai, which provides automated inventory. So we could go in and look at, okay, you have this pod that's running and it's sourcing this image. So we can go in and provide the same SBOM vulnerability scan, policy checks, all that good stuff in the context of runtime as well, to show you how it's evolving at every single stage. And then going back to the Log4j, response, when we looked at, I'll go into this on a later slide, but that was probably the first time I've seen like SBOMs being used, catalogs of SBOMs being used as a primary like incident response artifact, where, incident response teams were going through, the catalog of Anchor SBOMs and running a quick query in a matter of seconds against our API to say, okay, this is my list. This is like my burn down list, right? Where I have to go track down all these different, images and tags that are impacted by Log4j, and they sit within these specific repos. Okay, I can see this many are running, this many are sitting in my registry, all that good stuff. So SBOM is certainly a very valuable forensics like tool. And I would say also, from, working with customers and on Christmas Eve and stuff like that, it's very useful, right, to have the catalogs of SBOMs already built. So you're not going back and having to rescan everything and kick off the effort of first data gathering, right? The data is already gathered. It's just now you have to go through it. And then let's see, the last bullet, maintain content metadata for better vulnerability matching. So the metadata from the SBOMs, right, it allows you to kind of break down and see if there's CPEs available against that impacted package. And then, we provide that fidelity and the matching with Anchor to give you enhanced vulnerability matching. So, okay, this is a true positive, so you're not spinning your wheels over false positives that could be taking place. So 0-day recommendations, or SBOMs and 0-day events. Here are some recommendations, right? So use comprehensive SBOMs to identify all vulnerable components. So again, you want to focus on an SBOM that provides complete information, not just like, hey, here's a list of packages that we found in your source code repo, or here's the list of packages in this image. You want to be able to list like, what package types are in there, what licenses are attached to those packages and stuff like that. You want to be able to identify and have, all those rich components of the SBOM that are there, so you can, better identify the vulnerable and impacted components with high fidelity. And then ingest SBOMs to ensure security of third-party software. So if you're using third-party software, like, you could totally generate SBOMs against those with Anchor, and that's something that we encourage everyone to do, because if you're trusting someone, you should at least validate that what you're getting what you're paying for. Not really the case. You're not really paying for anything with open source, but you're getting what they're saying they're delivering, right? You want to make sure you're validating the security of your environment. Again, that's a information security best practice. In this case, we're just layering it on top of SBOMs in 0 days. And then we also want to retain SBOMs to quickly identify and locate 0-day vulnerabilities. So I talked about this before. You do not want to be in the driver's seat where you say, oh, wow, we don't have any data on, like, where this package sits. Or you may say, we have data on where it sits in runtime. Okay, well, like we previously talked about, that could be a problem, right? Because if your developers are just continuing at the same speed, that's just going to proliferate quicker. So you need to have that traceability back throughout the pipeline to say, oh, okay, this, you need to be able to tell that story backwards. You need to be able to say, okay, this pod originated from, got pulled from this registry, which was sourced by, or being used by this development team, which has this certain application that consists of these containers pulling from this source code repo. So you see, that's a little bit more complete story than just saying, I identified it in runtime, which is, good. It's a part of the story. It certainly is, but it's only one part, and we're trying to avoid those blind spots. So I'll quickly talk about continuous scanning and monitoring best practices. So again, you want to be able to build in that protection. And this is what we talk about at Anchor all the time. You want to scan at each stage of this SDLC. So integrating at source and development and build all the way through to runtime. And don't assume everything goes through CI/CD, right? Because there's developers out there that will just, hey, I want to test something. I'm just going to create this Kubernetes manifest that's going to source my local image I just built, and boom, hits your cluster, and you're like, wow, didn't see that. But hopefully you have something like Anchor that could pick that up and detect stuff like that. And then that's why you have to have things like that sit in deployment too. So things like a Anchor Kubernetes and mission controller that could say, if I haven't seen this image before, do not push it to my cluster. Or even more strict, you can say, if this image hasn't passed my policy, do not push it to my cluster. Just don't assume that it's following this streamlined process, right? Because there's so much different stuff that can happen in the middle of it. But you want to be able to integrate out all these steps and provide that security and compliance, via policy in each of these steps. So talked about runtime monitoring. You get the same kind of breadth and depth of analysis there. Continue to monitor running containers for 0-day vulnerabilities. It's certainly critical to see, even if you have them located in the source or in the CI steps, to make sure that they're not running as impacted assets. And then bringing it all together now. So take that SBOM-based approach. So using SBOMs, not only to build SBOMs for your images, but building them from source. Using something like Anchor, right, where we can promote software with trust. So we're saying, okay, we scanned it, we can validate your source code repo, we could, generate an SBOM against that, promote it, right, and you start generating SBOMs maybe against images that you're building from that source code repo, or you can provide scanning in your registry, right? So all your images you may have sourced from your registry from people that may circumvent that source and CI step. They may just push to your registry because they can. you could still generate SBOMs and alert on that. So being able to hook in there and scan, for policy-based compliance there, and then focusing, eventually, right, on deployment and runtime where you have policy-based gates, again, where you say, hey, like, I've never seen the Anchor will say, I've never seen this image before. And it certainly didn't pass my policy. There's no way we're allowing this to run in our cluster. And then, having that kind of catch-all with the runtime that we provide in Kai, where you go, okay, this has passed, Anchor policy, or it hasn't. And I'm going to alert, a security staff member or something like that can come in and take an additional look at this. But having that SDLC scanning at every single point in time, and then also having that post-deployment monitoring for that instant visibility to say, okay, here's my total list of impacted assets, and here's where they sit in runtime. I'll now open it up to Q&A for the last 15. And then go ahead and grab Anchor's software supply chain security report. It was published fairly recently. But it's very interesting. There was some stuff in there that really I found surprising. So I think it's actually a really good read. So that's all.
So Hayden, I'm not seeing any questions at this point in time. So what I'll do is I'll go ahead and give away our gift cards and give our audience another minute or so to think of anything they might want to ask.
Sure.
So these are for four $25 Amazon gift cards. Our first winner is Rolando S. Our second winner is Usman A. Our third winner is Felicity C. And our fourth and final winner is Charles P. So congratulations to the four of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I'll also take this opportunity to remind our audience that this panel was recorded. So following the webinar today, you'll receive an email with a link to access the on-demand. And it will also be living on the DevOps website at devops.com/webinars. All right, so we do have this question right here, and it reads, how often do you recommend generating an SBOM during the build cycle?
Yeah, so let's see, that's a good question. The best practice, right, would be to continuously generate that. So integrating it as a step into your CI or build phase. So that way, whenever you maybe make a commit against a repo and it starts building an image, to continuously generate and update that SBOM. And then what's really cool is you can, detect drift, or, how is that SBOM evolving over time? Not just how did it evolve from build to runtime, but how did it evolve just in that build step, right? So how many packages are being added, what types of packages are being added, and all that interesting information can certainly be useful, but definitely, doing baking it into that process, and having it be more of a continuous update to that SBOM and continuous scanning of that SBOM would be useful.
Awesome. And so can an SBOM help me find the exact location of components affected by a zero-day vulnerability, or will I still have to scan my entire infrastructure?
Yeah, so that's the beautiful part about it, right? So going back to okay, a 0-day has been disclosed. A lot of times, you may just have the package, impacted package. There may not be a CVE cut for it yet. So that's one advantage of having SBOMs as a critical cybersecurity artifact, is really, having that data already gathered. So when you're talking about identification, if you launch into that identification phase of incident response, and you don't have any data gathered, it's going to be a long night. So if you jump into that and you don't have any data gathered, it's going to be very problematic. So what we recommend, right, is using a tool like Anchor, where you can have that catalog of SBOMs. And like I said in the previous question, if you have that running continuously, that data gets stored, so it persists. So all you have to do is really sift through all that data to look for that impacted package. And, Anchor will tell you, okay, I need to go remediate this package where I found it in this registry or running in this cluster. Or it'll, not only tell you, what is impacted, but where it sits. So it will help you direct, your energy and your effort when you start moving into triage and remediation. Um, you know, when you have that data already gathered and you're able to see, okay, what is impacted, and where, is that impacted asset actually living. So, it certainly helps in that regard, because you don't have to go back and rescan your whole environment, with Anchor. That's not, how that works. So you don't need to take that extra effort and lift to go rescan everything to see if there's impacted software out there.
Awesome. So Hayden, that seems to be all of the questions we've received today. So I'll go ahead and turn the floor over to you one last time to leave our audience with any of your parting thoughts.
No, I just want to thank everyone for tuning in to today's webinar. And again, check out the survey. If there's any questions, feel free to reach out, either directly to myself or, go to the Anchor website and check us out.
Well, Hayden, I really appreciate you taking the time out of your schedule to be here with us today and share your expertise on this topic. So thank you for being here.
Oh, thank you, Cody.
I would also like to extend our gratitude to Anchor for sponsoring today's webinar. And my final thanks goes to you, our audience. We really appreciate you taking the time to be with us this morning, this afternoon, wherever you are. Please take a moment to fill out our post-webinar survey, and we really hope to see you at a future TechStrong Learning webinar.